Here. This is the CH570, I believe. And oh, I have booster. It has 100 megahertz. Yeah, let's do it. 2 hours into the stream? Yeah, we just started. My friends. Scope on. Let me create some space here. Put it a little bit down. No, you didn't miss anything, Basil. We are just about to start. Now I don't miss any super stickers, super chats, raids and everything. But we didn't test the Twitch things. Whoa, who needs to warm up? Huh? Okay, so what is... I don't have many pins. PA7. Okay, let's do PA7 then. Okay, PA7. Oh, my mouse doesn't work. Okay, PA7. What is this? I want... Wait. I want this. Desktop plus oops. No. Here we go. Oop. Let's put it up there. Now you get some eye cancer because I have to use Moon River. Okay, maybe there is like preferences theme. Oh, dark theme. There is a dark theme. Yes. Okay, that's okay. Yeah, whatever. RP 2040. Oleg. I will show you something. You are not far off. Next week we do RP 2040 project. Next week will be grand. Wait. I will show you what I purchased. Here. I got this one here. I think I talked to somebody at some point, but I totally forgot. Anyways, I purchased this device here twice, but it will be shipped from abroad, so it won't be probably here Friday. Oh, it is with PS RAM. It has, I hope, uh, 16 megabytes flash, 8 megabytes of PS RAM. So next week we play with this thing. But this week we play with I had to restart to apply save changes. Okay. And restart. Fractional frequency dividers, yeah. Wait, this is not, what is this? Okay. Let me do CH570. I need to example what do we do? UART SPI. Crowd supply. Yeah, it was poked a few times by crowd supply themselves, but I'm not very, I don't know, keen to do any support whatsoever. I might consider partnering up with somebody, maybe Seed or I don't know. Extra bucks, yeah. Yeah, would be nice. We can maybe do something at some point, but I'm more into exploring than into. Why is this? I cannot zoom in. Doesn't. Okay. I need to open an example. What example would be the best? Okay, wait. This is system clock. Do we have DMA here? DMA is UART, PWM, SPI, timer, SRAM. Wait. Clock tree. No, that's the clock tree. Where's the DMA? General purpose timer. DMA control register. Okay, you know what? Let's try the timer then. I should make a new solution. New solution path, and let's do okay. Oh, restart again. Oops, not this one. This one. What the? And restart again. This is old school software. Okay, thank you, welcome. Project Explorer, now we open TMR project here, TMR. Okay, that's an example and we will just modify that. What is this? This is too big. Nobody needs that. Nobody needs that. And we don't need that yet. Okay, timer mode. Blah blah blah. Set bit debug init. GPIO pin 7, A7, that's perfect. PWM cap mode. That's, yeah, I want timer. Wait, what is timer mode? Timer mode 6. No, it's 2.4 like Bluetooth low energy, but not Bluetooth low energy. The 572 supports Bluetooth low energy. The 570 doesn't have the license, but probably could do as well BLE. What's the difference between GPIO set bits config push pull 5 milliamps, timer init frequency, sys, the 572 supports both probably. I mean, it's BLE runs on 2.4. It's an open frequency, I believe. Is it? Yeah. Timer. What is this? Let's do 7 as well. I don't know if it supports. Yes. Bluetooth low energy. That's. Where's the 6? PA, I can't see 6 on this board. Okay, so PWM mode. Let's just try that. And why is the UI so small? Okay, let's do it. Download. Five, 7. I think it's Q. Query. What? Twitch follow? Yeah, there isn't. Oh wait, we have no Twitch follow. Wait. Is there a Twitch follow? Let me check. Yeah. Followers only. Event or emote only. Followers only. What does that mean? Message, delete, resub, subgift. Yeah, that's follow. You need to subscribe. Where's the... I don't want to see properties. Where's the output? Problems, console. There is a console. Okay, here we go. Upload it. No need to upgrade. Options found as... Oh, yeah. Configuration. I need to program, verify, reset, and enable, apply, and close. Okay, here we go. Choop. Ah! There is something. No, wait. Here we go. Okay, that example works. Trigger. Here we go. What's the... Okay, here we go. That's 50 microseconds per... Can I copy that project? Can I copy the whole project, because I don't want to change the example. Project name, video, and then okay. Let's see if that works. But this will not work with, wait, tools. I need to build this one. File name, video elf. Configuration. Browse, and then video, and then we need to clean up afterwards. Okay, so. Okay. Capture buffer. That's interesting. Okay, count mode, PWM mode, timer mode, common. Let's remove everything that we don't need. Thank you. Copyright notice. PWM. Hey, wait, there is a DMA mode. Where is that? Oh! Kasper! Thank you! That's amazing! Did you hear that? Resub. That's cool. Oh, let's try the DMA mode then. Shall we? PWM DMA mode. What is count mode? Count is basically cap mode. This is count mode. It counts. Interrupt, enable. This is just a counter, hardware counter, but it's cool. Timer mode. Okay, I don't know what that says. That's LED. Wait, PWM. Chip ID. DMA mode. Okay, encoder mode. Oh, that's cool. Increment, decrement. Oh, we can do a digital encoder. That's really cool. But I don't need that. And if, while, and if. Okay, here we go. While one. We don't have an interrupt handler here. That's cycle end. That's the timer interrupt. Encoder IQ handler. Okay, we don't have those handlers. Okay, here we go. PWM DMA config. Oh wait, the timer interrupt was used there. Timer interrupt, count mode, PWM DMA mode. Okay, let's remove that. I don't understand Chinese, but here we go. It will probably restart the DMA transfer. We can learn how the DMA is working here. I believe we can close that. Don't save this one. We can close this one. Remove. No, cancel. Wait. 3 project folder on disk. Okay. Here we go. Let's build it. And let's download it. Select project. What is encoder for? Yeah, you have the rotary encoders that will flip just like the 2 bits, and then you see the orientation will determine in which direction you move the step. I will show you one. Give me a second. I just need to build project. Okay, here we go. Thank you, Jens. You're welcome. Okay. Did it do anything? Wait. We modified the wrong file. No. Oh no. We edited the wrong file. Oh. 2 mains and okay, let me copy that original one, put it here. That's all right, that's all right. Here we go. Yeah, it was us. I just fixed the other one. Okay, let's download it. Oh yes! Okay, DMA is working. Can you see that? Foo! Hello! You missed everything. We are using the WCH 570. That's a Tencent RISC-V that runs at 100 megahertz, and we want to do video with that one. Generate audio, no, video actually. This will be interesting. Okay, so how does the timer mode, PWDMA mode, encoder mode? Okay, so PWM buffer 100, not VGA, like analog video, AV. I don't know what, how it's PAL. No, it's not PAL. Bass, F-Bass. We have no DAC, but we will do a simple resistor ladder. Something very simple. What is this? G frequency PWM cycle configuration. Okay, peeps. This is a ramp. This is a ramp. Low level PWM in it. We need to check, select wave polar refer, polar type definition. Set repeat times refer. Okay, blah 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 blah. Mode loop. DMA config. That's interesting. Enable. That's timer DMA. But is there... Yeah, I did too. Foo. Charles did NTSC. We could probably like send on NTSC and receive it on the analog TV that I have here. Timer config 100,000. Wait a second, startup. No. Source, binaries, wait, object. Where is the startup? What frequency is this running on? Where's the configuration? Oh, here. Clock source external 100 megahertz. Okay, let's increase. Black and white. Let's start with black and white and the sync signals. Yeah. Okay, so frequency, system frequency divided by 100,000 is like 1,000th. So let's change that to 1 and see what happens. Okay. Can't see anything here. Okay, let's do 10. Okay, we can see something. There is something happening. 10 microseconds. Okay. Yes, done with Node-RED. We are working with a new risk. What is this? 1 microsecond division, we have 4 microseconds. But what? Okay. This is we have 4 microseconds per. Yes, it's risk V or risk 5. Okay, we need to change the duty cycle to 16 or something. Cycle configurations times 10. No, we don't do 10 here. This is also times 1. PWMs times 1. Wait. Cycle configuration times 10 divided data with duty cycle. Oh wait, that's the wrong. Yeah, we want PWM mode anyways, I mean DMA. Not red with yes. Oh, 200, okay. Times 16. Let's do 8. No, let's do 16. 32. 16. And wait. Let me do spaghetti drove you off. What? Holy flame. 16. That looks like configuration. We have 32 mode loop. What is this? PWM init. Repeat times, refer to repeat. Yeah, okay, let's repeat 16 times because otherwise times 16, that's also not true anymore. Hey Arch. I don't know what it does. What does that mean? Let me do Google Translate. Where is it? Lens. Oh wait, translate. Okay, here we go. Enable count overflow interrupt. Enter the port when count reaches 100 cycles. No, when it reaches 16. Let's just interrupt. Okay, this will not work. I can tell you that. Here you go. Oh, it still works. Oh, interesting. It looks like it. Wait, let me single one out. Oh, it repeats 16 times. Okay. I just repeat once. That will die because of the interrupt. Single. Huh? Oh. Okay, I get it. This is what needs to be like restarted. Wait, horizontal. Here, that increases. You can see 16. Oh, it increases and then it stops? What? No. Does it decrease already? No. It increases to 16. Okay. Let's take a look. Oh yeah, we have 32. Why do I do this? I don't want this. I don't want all of this. Cap flag, also no cap flag here. Also no this. We just need 32. Oh, it needs 4 bytes aligned. That's interesting to see. $500 p. Blah blah blah, Mr. Freeman. Here we go. Remove that. We don't need that. 16 cycles. Do it. And then the start, restart, whatever. Print. Print. We don't need the print here. What is this? What does that mean here? The text. You can't see. I can't scroll upwards. Here. I will tell you what the text says. Use a single DMA function plus interrupt. Please note that the interrupt must be disabled after completion, otherwise the interrupt will be reported continuously. And then we have clear interrupt flag. And then we have timer interrupt. Okay. Timer DMA end. Okay. Cycle end. I'm wondering if we can use that to refill the line buffer. I like that. Especially for newbies. Yeah. Okay. Timer. Does it have PLL? It has PLL, I believe, but I won't use it because it's not accurate enough. I did VGA once with the internal PLL, but it's very jittery. You lose the sync sometimes even. Okay. I don't need prints here. Debug. Yeah, we can leave it there. It's interesting. Okay. Let me compile and download it. Let it run. Oh yes! Stop. The printf was slow. Here we go. There is the long pause. Okay, but we have complete cycle here. Oops. From 0 to hero. Yeah, there is like, this is 0. Whoop. 15, I don't know what, it might be, whatever it does, it's alright. Now let's see what was our duty cycle here. It's 160 nanoseconds. Is that good? What is, let me check. Yeah, our cycle is exactly 160 nanoseconds. Okay, let's do drive strength. It seems so. Here. 40 nanoseconds. No, we can halve the resolution. Huh? What is this? 500. We can do 500 as well. Let's do that. Steeper function here. Let's see how that looks like. It will overshoot even more. Okay. Oh. Yeah, it overshoots even more. Where is it? Here. Look at that. It overshoots even more. Let's leave it at 5 milliamps, okay? Shall we? Yeah, I'm wondering if we can do proper video now with okay, PAL video timing specification. Let's see what we got. We have 12 kilobytes of of RAM. We need 64 microseconds. We have 160 nanoseconds right now. We can maybe do a low pass and then we have perfectly fine. What is this? 160, 64,000. divided by 160. Whoops. How many pixel is that? 400 pixel! What? It's perfect. It's perfect. We can do video with PWM. Yeah, I can do that, or I leave it at 400 because that looks tiles. Now I would do PWM Rickroll. PAL TV interlaced. $140 nanoseconds for what? Yeah, 64. That's 200 nanoseconds per pixel. Oh wait, yeah. Oh no, you're right. We have more. Like the visual, we have the. It's only 52 microseconds. The total line is. If we have 400, what's the rates? Okay. 400 divided by 64 times 52, that's 325. So it is what it is. And we have like, yeah. Okay, here we go. So 64 microseconds is the complete line. So I have 400 with 160 nanoseconds per pixel, per value. I have a resolution of 400. If I divide 400 by 64 times 52, we get 225, which is almost like 200. Like we can crop it or whatever to do like 320, which is perfect. Let's leave it like that. But we have only the black level is, what's the black level? .3 or something? Yeah, 0.3. How much do we lose? $16. What? No. What? No. It's 320. Am I wrong? Yeah, sync is negative voltage, but what is negative voltage? You can just modify it. So if we have like, this is 1 divided by 16 times 0.3, we lose, oh wait, no, 16 times 0.3, we lose 4.8. We have 11 gray values in the end. Negative voltage, you can bias everything. Yeah, we can just do that. I did that before. That's all right. Or we could also bias the ground, virtual ground, but It's not good because everything is connected here, so it will be working. Also, we have like this overshoot here. we can use that for 0. Okay, let's create a line. So yeah, let me do the calculation. We have now 160 nanoseconds per cycle per complete round. Where's my calculator? I lost the calculator. There we go. Okay, 64,000, that's microseconds, divided by 160, 400, divided by 64 times 52 times 52, 325 pixels. Am I wrong? Let's test it. should we just test it? Let's not waste any time and run it already. Okay. Line, video line. Line 400. Oh wait, 32 bits? What? No. Are you kidding me? That's already wasting so much. Does it? Oh no. R16 DMA. The DMA works on 32-bit values. Ugh, gross. Yeah. That's alright, we have 12. We have to live with that. Let's just go with that. DMA mode loop. Interesting. Can be. But I think there is a shuffle or something. We would need to like flip the bytes around. Let's start with what we get. Video line. The old line. Here we go. Init video line. Black as set video line sync. Yeah, I have this. Black. Sync. And we have does that work? No. No, not pixels per line. Yeah. No, pixels per line. 400. Let's leave it like that. What is it? That's sync front back pixels sync what? Pixel sync front back const and xres through 300, and let's do how many? How long is the front porch line sync? We will find out. 4.7 divided by 0 on 6, 29. That's 29. No, to PWM peripheral. But it's we might need like to consider that there is reload or something of the PWM peripheral. I'm not sure about that. Let's see how it turns out with the sync signals, because we might just need like we might just use the back porch to reload the DMA or something. If that is consistent, then we are fine. Or we set it in loop mode and then try to whatever. Front will be, what is front porch line blanking front, wait, burst, what? Line period, line blanking, what burst, what's blanking here? That's the sum of that. Yeah, that's the sum of, oh, there is a burst. Okay, yeah, the burst signal, we don't need that. That's the blanking is the complete thing. Burst. That's the fields. But we can cheat the fields. We can do like, yeah, but what is the front and back? Wait, let's see again. Burst start front porch 1.6. That was 10. 10. So front is 10. pixels back, but we might need to shift it. Pixel sync. We can also, yeah, whatever. This will be basically minus x. Oh wait, no. Let's not do it like that. So we are here 40. Your message didn't go through. What? Polyflame? Somehow my chat in this in OBS doesn't show, but I can see on screen and I can hear it. It just Tommy's speed is set to like very slow. Pixels. Okay, that's 30, 40. That's 40, 60, 41. 41, then we have 70. Here we go. Okay, pixels per line. Pixels per line. Okay, video line. Ah. PWTMR enable. We can do interrupt, and we might want to disable that to have. Yeah, that's alright. I mean, it's a 32-bit processor. Debug init. Yeah, we don't need debug here. Where we go, we don't do debug. What is, why do we, no, we don't need I here. What is this? Source, okay, 5. Blank sync, okay. For I plus plus. Oh wait, no. Okay, we do sync. Video line I equals 0. Black level const int, let's do level black is, what was it, 5? No, 4. Let's do 4. Level sync. Sync is 0. Level white. I have no clue. White 16. Does it work like that? I don't know if the PWM ever gets like, yeah. Does it count like to, does it get like fully on, full duty cycle. Yeah, but it's the level. Okay, whatever. That's level sync. And then black level. We can do gray. Do we do gray or gray? Gray. That's 8. No. 6. 6, 5. 12, 6, 10. Level sync. Oh wait, level black. Black. Wait. Okay. What? What did I do? Let's copy that. Copy paste errors. Level gray. Level black. And then pixels back. Pix XRES. Pixels front. Okay. Set video line sync. No, black. Okay. Let's run with that. Wait. Oh, 3 errors. What errors do we have? Variably modified. It's not variably defined. Oh, that's C. Stupid C. Does that work? It won't work. That's why I hate C. Oh wait, that's yeah, 400. Good. This doesn't work. No. A low pass. No, we didn't do that yet. Okay, let's do some prototyping here. breadboards. I need a breadboard first. Here we go. It's way oversized. We can probably just plug it in and see what happens. Yeah, they just ripped off probably somewhere. VCC GND. Okay, A7. First, we need some ground. We need ground. Okay, so we start also shorting all the time. This is ground. We need signal PA7. Can someone calculate the low pass filter values that we need for 160 microseconds at 5 milliamps? How do we calculate that? We just see what happens. Just plug it in already! Mixella stuff, yeah, he's great. He's like very like-minded regarding like the effort he goes through to build something unique. Okay, now how do we do low pass? We need a resistor and a capacitor. Where is our crap box with different values? Where are Okay, I have some resistors here, some capacitors. Capacitors should be also here. Filter. Huh? What is the filter in terms? We have a frequency of. We have a duty cycle of 160 nanoseconds. We have either 20 milliamps or 5 milliamps drive strength. If you need that value. Where are my capacitors? Here. Okay, we got some capacitors. Oh, we can do. You know what? We can do even like a variable resistor here. That's 1000. And this is the capacitor. We just need to do that. And oh, and then we need also I don't have variable caps, but we can do. Okay, now we have 1000 ohms and a really small cap. Probably not enough. Let me rotate that. That's a basic low pass filter if you're asking yourself. It's never getting flat. 1000. Oh, there is FFT on. Oh, we also need okay, I need maybe a bigger cap. Let me try something bigger. What was that? That was 100 pico, 100 pico. Let's do 1 nano. Oh, another in parallel. Okay. Do you think like 2 pico? 1K and how many? 27. Oh. Okay, let's try 1K. I have also basic resistors. Let me do that. Thank you, Basil. I will try that. Let's try just a resistor and 27, you say. Let me find 27 here. 47, 65. I have 20 picofarads. Okay, let's check. Yeah, 20 does nothing. How does that look like? Huh? At 1000 20 does nothing. 4 point. Okay, let me do 10n. 10 nanofarads. That's way too high. Eight megahertz. FFT. Let me check what we can do here. I can do 30 picofarads. That looks like still yeah. That's 30 picofarads. Try 1n. Yeah, but that looks like, and we have the restart of the. Yeah, that's too slow. You're right. We need something else. Yeah, we have here. That will be in color. We just assume this is color. But okay, let's leave let's leave it like that. I'm wondering if it supports the DMA supports the SPI is supporting 1 bit or lower resistor value, higher cap. Okay. Or what? Okay, let me try that calculator. Oh, that's frequency is what did we do? .25 megahertz. Quick FFT. Yeah, that's not. We need to also make the thing repeat. So I don't know if it should be looping. It should be looping. Let's see if it's looping without the interrupt. Yes, but why does it? Okay. why does it need like that long? Why does it repeat here? I don't get it. Look at that. It repeats. Am I stupid somehow? That looks like it's inverted. Front. But, huh? Cursors, measurement. Not that. Period. Okay, we got a period measurement of 255. What? Microseconds? Something's off here. Okay, let me do something else. Let me do a line sync. Pixels per line. Okay, level black. I will just do the sync and let's see if we get like okay, it loops. It just loops. Now let's do half of that. Level gray, and then let's see what happens there. Wait, compile first. That looks correct. And we get 63.34 microseconds. So we might need to add some cycles here. It's maybe the sync pixels front. Level sync. Let's try. No. Oh, it's actually inverted. 164. Yeah, that's not precise. The measurement. That's 0. Is that inverted? Why? Oh, are we counting how does that? Okay, so let's do -16. Okay, let's do that. But why is it 160 microseconds? That should be 664. Are we doing something wrong? No, wait. Oh, wait, I looked at the wrong position here. We have 250 microseconds. That's completely off. Why is that off? Did I calculate everything wrong? Oh no. Ah! Here. Yeah, that's why we didn't get the right values here. Ah. Uh-oh. Punish the rookie. Video signal with 10-cent microcontroller. I need to change that to... Yeah, that's not... Did I calculate everything wrong? I thought we had like the right duty cycle. Was it... We tested it with 16. One division was 160 nanoseconds. I don't get it. PWM init, repeat times. Repeat is 1. Maybe 0 here. Let me check that. Ah! Low level. Wait. Is this the invert? Wave polar type. And then we have the culprit. High level 0, okay. Here. I don't need to invert it anymore. So that goes away. We have one less repeat, but still it's still way slower. Okay, what do we have? Period time is now... Now it's correct. Delta X is 60... Was it the repeat? 100 megahertz. Now let's look at that. Now we have the perfect... Now we can try filtering again. We have a delta X of the period is 64 microseconds. which is the line, and we have line frequency is 15.625. Now we need to filter it. Let's try the sync signal. It's not needed anymore. Okay, so this is still all right. Yeah. Oh yeah, that looks like what we wanted. Look at that, we get some color. This is what I wanted. We might need like to adjust the front and back porch a little. Now let's get to the filtering, shall we? So, lower value, higher cap, 100 ohms. Or wait, let me do 20 milliamps drive strength. Okay, doesn't change anything because that's limited by the... Okay, let me do 100 op amp, 100 ohms, and no, it will just do color instead. Okay, capacitor is too high. Okay, yes, probably, I don't know. Patient heart rate, until it will be dead. Now the 100 ohm. I don't know how to do the impedance correctly. This is too high. That's too high. And that's 1 nanofarad. Let me do less. That was 1000. We need something 300. Let's try 300. Nah. $300 is too high. 100 pico. What? Casper? Shall we just connect it to the TV so you can see it? Go brush your teeth and we will just connect it to a TV and see what happens. Scope measure. Oh wait, can we do that? How do we do this? Impedance 50 ohms. Ah! Yeah, it has it built in, but what did it do? No, no, no. Okay, it drops. The 1000 ohm is, yeah, we need like an op amp for that. But if we do, let's do, we have 50 ohms from 3.3 to 1 volt will be 100 ohms. Let me do that. That is too high. $75 and 375. But we need to drop the voltage to 1 volt at the end. Is this correct? Why does that drop to... That doesn't work. We need like... too low. 20 milliamps. Oh. 100 ohms. Yeah, it doesn't work. Isn't 50 ohms? What did I do with the ESP32? It was like, let me check. I did 300 ohms. Yeah. Let me check. That was 300 R to R. I used the R to R. I used let me check that. Here. Nothing better than my own reference here. Huh? Where's the... Here it is. R to R, and I used... No. No. That's not it. That's wrong. I used 300 and 150 and I think 75. 75 in line. 150. Let me check. What do we have? $100 ohms will be fine as well. 300. Do I have any? 220 and 100. Yeah, this will be also right. 220 and 100 ohms. Okay, that's 220. $100. And now we need to pick the right. That will be alright. I'm not worried about this one. Okay, let me do this. We can just let's assume the signal is alright. Yeah, that doesn't work like that. Bandwidth. Interesting bandwidth limits. Changes that. 3.3 volts, yes. Test, yeah, let's just connect it. CRT time! Here we go. We don't need antennas. Where we go, we don't need an antenna. Here. Why is this? This is not long enough. I don't have an extension cord that's long enough. But I need the CRT here. Okay, let me grab an extension cord for this. No luck. How is bitluni not having an extension cord here? HDMI and GPIO soon. Why is this? I don't have a free socket here. Wait, this one can go. What? Viertelwissen. Hallo. Welcome people. We're trying to test our stuff here. The TTS worked with the notification. Oh, we are generating a video signal, but the signal level is too high. Where is it? Okay, AV. We need crocodile clamps. Crocodile clamps for the video signal. Wait, didn't I have one that was already prepared for that? Okay, let's use this. red one. Let's hope it doesn't burn or something. That would be terrible. Ah! Why does it... No, this is not audio. Video. There we go. This will be ground. I need to be careful. Wait, this is not ground. Foo. Okay. So our video signal. Yeah, worst. Yeah, it doesn't matter. It is a fuse. Oh wait. I should record it in case everything burns and we die. Okay, I'm recording, so if I destroy this mini TV, it's all your fault. Okay, here. This is the ground. Ground coming here. And this is... First, no, it doesn't work because we don't have a vertical sync. We have only the horizontal. But it should show something. Let me record that as well. Okay. Oh, it drops to 1 volt. We get a gray value. Do you see that? What? This is... I know there is a shift. Okay, this is perfect. Okay, we can shift. Oh, this is cool. This is cool. Okay. Okay, we have the horizontal sync already. Let me just make the box shift the values a little bit around. So let's do let's say 110 and 220. 220. Oh, the cables are everywhere. And you will see the gray box will start like around 100 pixels. Okay, let's compile. Yeah! yeah, okay. Works. And this is it's PWM. Oh, Casper, I hope you were listening to this. Okay. Now we need the vertical sync and we are done. we need the character ROM. Yeah, it is terminating with 75. That's why it looks like that. So look at that. We are at, what's the level? Voltage level is let's do measurements. Max, it says it's at 1.71, but that's just the overshoot. The gray. Okay, we might need to gray. How many gray values? We have what is it? 11 gray values because of the sync that we need minus 0.3 volts. Yeah, I might need to play around with the resistor values. Probably don't even need the capacitor or the resist. I can use the resistors, but I don't need the cap. If I remove the cap, it probably just is alright as well. Yeah, it's perfectly fine without the cap. So we just need to put a resistor in between and then... Oh wait, the cap wasn't actually working properly. It's so off. It will probably generate a color signal. Okay, enough recording. Now let's do the sync signals. I have 220 and 220 C is 1 nanofarad. That's completely off, but we can play around with that later. I just want to do the sync signals so we have a success for today, and if we can display some pixels, that would be amazing. God, it feels like I will short it and destroy everything here. Let's leave it like that for now. I will move it away. Now we need to yeah, I know, that's what we want. We have like an intrinsic voltage divider here. It's the same working principle that my older implementations of VGA did. It worked the same way with a resistor ladder, and then I used 75 ohms or 80 ohms resistors, and that would drop the voltage properly. Okay, now we want not interlaced, non-interlaced. Fuck me. What? Have been playing with 150? Oh! 22 nanofarads. I don't think I have 20. Okay, maybe I have some, but I will notice that 150. I have 150 here somewhere, because that's the ones that I used before. Should be even a box with 150 printed on that. I have 150 here now. Yeah, 150 and 22. Huh? Where shortener continue to the destination. What is this? TinyURL and shittified itself. Oh, that looks good. Okay, so this is what we get. I will open the URL in my other browser. Fuck me. Why? Just open the URL. Huh? Oh, that's weird. Don't search it, open it. Google doesn't open it. These are assholes. What? It's so strange. Why doesn't it just open? Huh? Look at that. Look at that behavior. I dropped the link. What? Okay, you know what? Where did it open? Yeah, they will probably be sued by EU for that. Okay, copy link. I do a full URL. Okay, that works. They just don't want tiny URL. They want like to probably suppress, discriminate against tiny URL. Okay, I got this one. Thank you for that. I will try it later. Let's do the sync signals, but I need to... I think Martin Hinner. Okay, that was our URL from before. I think you always do the start of the first field. Long sync, short sync. Half the line. What was there was like this. Okay, non-interlaced. From field 1, which at least lines. Okay, this is non-interlace mode. Okay, here we go. That's an unofficial. We'll start the first. What is it? Okay, anyways. How do we do the DMA restart? RQ handler, clear DMA and timer IT config interrupt. Yeah, there is on. Yeah. IT cycle and TMR clear. Okay, that's just 2 writes, and it will be, yeah, it must be that one. I can remove the if probably. PWM enable loop. We just need to figure out mode loop. We don't do the loop anymore, but we need to figure out how long it takes to reload. PW enable. We need to reload the DMA again or not. Okay, I will disconnect this one. Now we will mode loop, okay. Because I need to restart it. DMA config. DMA config. I would need to restart it right away. It's not config, it's not loop, it's, oh god. The buffer, yes, but we want to keep it minimal for now, okay? Let's do all that optimization later. You don't want to wait until 4 o'clock for me to finish here. Ah, that's the wrong mode. Single, okay, here we go. Yeah, in the future we can try that, for sure. Sure. Okay, single. We can prepare things and whatnot. Do we need to restart DMA after that? Okay, we will find out if we. Yeah. That looks weird. Single, no, stop, run, stop. Okay. Let me just do the output signal then. The actual pin. Let me try white here. Also, this will be 10 and this will be 320 again. No, It stays at the last value, I believe. It runs and then stays in the single. Timer, PWM enable, timer enable. Why does it, do we need to do, okay, let's try that. Let's see what we need here. White is the new black, yes. I don't see anything coming. It's all the same. Let me do only 0 and full, so we have a reference. Is the new ping. Okay. Okay, it stays at 0. It ends and then it's done. Do I need to PWM init first? That would be terrible. Yes, okay. But now our period is 71 microseconds. Ay, no good. What if I remove those two? And okay, that doesn't do anything. Doesn't do anything. I try all permutation, just removing it bit by bit. Doesn't do anything. We need all of that. Do we need that? We don't need that. Okay. So DMA doesn't need to be reloaded. We have 66 microseconds. What? Perfect. Okay. We don't need to reload the DMA. But we need to init it. So if we remove a few pixels, const and from the backport pixels reload, let's say 10 pixels, okay? Backport is long enough for that. So we just do reload. Oh, Christian, you missed it. 10, we need a little bit more. 12. We need to reload manually. Yeah, we need more. 20. Let's do 20. sync signal. It's confused by that. Let's run with 20. Oh, did they compile? Oh, that's too much. 1 microsecond too much. So let's do 15. Wait, we can calculate how many. We don't need to iterate it. We have 160 per pixel. Yeah, 1 more pixel. Ah, right. Yeah, it's a little bit off. Huh? Wait. Huh? Doesn't change. Huh? The period time didn't change. Huh? What kind of sorcery is that? No, it's not. Now it jumped. Oh, it needs to be a full for. Oh. Uh-oh. It died. Okay, let's program it again. Yeah, if I do more than 12, it jumps like by, oh no. Okay, we need to optimize anyways. Let's leave it with, I think 13, we had like 16 as the full for yeah, 16 pixels. So that's what we can save on that. But yeah, we need the black level here. Oh, is there some jitter? No. Wait, I need to do it here. Yeah, that's the impedance. Okay, black level. We need to shift the whole screen. Let's do pixels front is 20, 31, okay. Now it looks more centered. That's the image, but should we increase? Let's do it like that. Since this is pre-calculated, that will be level black plus level white wait plus J modulo I think it's 10 or whatever. It is the 4 12. Yeah, I think it will. Let's see if we can do. Yeah, grayscale! Grayscale! Oh, grayscale! We have the grayscale, peeps! I don't even see the grayscale on the oscilloscope. Oh wait, that's stopped. this is the signal on the oscilloscope. It's perfectly working. It's perfectly working. We can fake some color here. Yeah, but it doesn't have a sync. Okay, now you didn't trust me that we can do it. We can totally do it with 10 cent micro. Okay. Okay, the line sync is a little bit off, but it seems like it's not complaining a lot. Pink sync. Yeah, we need some. Okay. Fifth, I need to do the following. We need to change the line. Okay, let's see what kind of stuff we need. We need long sync, short sync. What's the long sync? Okay, let me do the okay. That's a good idea. I will do a pre-calc of 2 long syncs and 2 short syncs, and then move the pointer. So let's do video syncs, and that will be 1600. Ooh, that's the most of our RAM. We might need to pre-calc something. Let's just do set video lines things. No. Set video syncs. It might not even go through. We need to fix also. Yeah. Just do a loony logo bouncing off the. That will be hard. Yeah, never get the corners. It will bounce, and then whenever it seems to be going to the corner, it will just divert. Troll. Okay, video syncs. We need. I think the sync will be like. Oh no, it's black. I think it's black. We could fake the sync signals. We can invert the PWM Or we could do them manually in the timer interrupt. Wow. Okay. This is like, we don't need DMA for that. If it's like, we can set the time, the PWM, repeat some cycle, oh no, the cycle count is like really rigid. But if we can do the short and long sync, if we can do like high and low, just go full scale. Oh, I see some optimizations there. I see some optimizations. Or let's do videos. Yeah, let's do video syncs. That's 400. Lines per pixel minus pixel sync. Pixel sync. And we do what I see. I see a possibility to make it, to optimize it. Wait, long 12K RAM, but I will optimize a lot. This project will be amazing. It will we can do we can do amazing stuff. Wait, can we repeat the line 2 times? Maybe. We can do arc. Yeah. I'm impressed that even the rate worked, like the rate sound. Did you hear the rate sound? That was cool. The new sounds that we recorded just with Audacity and this microphone. Okay, video line and sync, level sync, level black. Oh wait, it's half the per line divided by 2 pixels sync, and then we do the same again. So long, short. That will be basically same. And we will do different way around. Here. Like that. Oh, we can save even more memory, even with this method. Anyways, we need to reconfigure the memory as well. Set video syncs, that will be the sync. Wait, no, we need to sync here. Okay, like that. And we need line number. So volatile line number is 0 and this is the last address divided by 4. That's like times 4. Okay, we can fix that. Let's do no. $32. Hä? Line mem, and then that will be const. And we could do like all the lines. How many lines do we have? This will be 312. That's yeah, but we have non-interlaced mode. Yeah, there is no full res because interlaced sucks. That's why we don't do that, and we do the following. We do all the lines here. Line mem. Let's start with long. So that will be basic. Oh no, that's not video line, that's video syncs. Copy paste again. Okay, so we start with long and will be long. Once again long. Then we have long short. That will be video syncs plus $800 because short because it is. Then we have short 1600 short. How many? 2 short, and then we have video line. Video line. We can. Oh, it's half the resolution, huh? Do we 300 by, oh no. Wait, yeah, that's 312. 320 by, what is our real resolution? 6 to, yeah, let's start with video line first. We could do like 2 lines per pixel, but we can also I don't know, 6, how many is it? 304. Okay, that's 5. I really want to save it hard. That's 10. 1, 2, 3, 4, 5, 6. Oh wait, we can use that. Line numbers. $300, what is it? 4 lines. Wait, if we start with, yeah, and we started at 0. Yeah. Alright, that's 300. We might want to fix that and do alternating whatever line buffers. And now we conclude with short. Was it 3 times? Okay. Okay, peeps. Now we need to reconfigure the DMA. Oh. We start with line mem. Line mem 0, and that will be times 4 plus 1600 yeah. That's it. And here we need to reload it, but we also don't want to reload it like that. We just go and see where the pointer is set. Oh. Interesting. DMA is still on. It doesn't do much, but it took so many cycles just to set the address. Okay. Line number plus plus if equals, what is it? 312. Wait, starts, yeah, 312. 12. That might be an oddity, but I hope it resyncs correctly. Okay, begin line mem line number and yeah, it has, like, it only uses 16 bits. It has only, like, the SRAM is 12 kilobytes, so it will probably fit within that. We could use even that one. And add I would say because we don't need to mask it twice. I guess it will be back plus what is it? I hope it's not multiplying here. Okay, 2. Let's do it. Okay. Let's see how long that line takes. Ooh. Yeah. Now the line takes too long. Why is the period? Yeah, I think it's off, the timing again. Why isn't it the period working here correctly? Mode, measure, period. Okay, let me get it from here then. Shoot. Wait. Come on. Okay, the period is 60 microseconds. Huh? Oh yeah, it measures wrong here. Okay, let me do cursors then. peak to peak. Let's trigger, okay. Manual. Okay, here we go. Come on. Where do I set it? No, I want to move it. Foo. Select cursor. Here we go. Yeah, it's too long. It's about 68. So changing the DMA value takes really long. Okay, so let's do... we don't have a lot of space there. Let's do 24 in the back. Ah. $67 still. Ay. Why does it take so long? Okay. Pixel sync. Oh wait, we need to reduce it as well. No, we don't need to reduce it. We need to, yeah, let's do 30 then. No, 28. That's the most we can go here, I believe. Otherwise it won't go to black level anymore. Does it get worse? How can I move it completely? Yeah, here. Damn it, move it already. Here. Now it's still 67. The reload of the .30 cycles reload of the DMA is too long. What do we do here? We need to clip the image. Oh, good night, Basil. Thanks for the help. $67, that's like 3.7, let's measure it. 3.7 divided by 0.16 equals 23 more pixels that we need to sacrifice. Okay. Let's do the following. Let's do 300. Then do 50 and do 48 and see if that helps. No. What? No. What? Let's see. It's still the same. Huh? Do I do something wrong here? The reload is pixels reload. Let me try to just get a lot clipped. Or is it like the minimum time that it needs? No, now it's completely broken. Yeah. It just doesn't work. 148. Oh, it needs to be a multiple of 4. It is 100, yeah. 48, 64. Let me do that. Did it die? I think it died. Yeah. No, doesn't like it. Let me remove that. It's in an odd state. Let me disconnect. Okay. It's still the same time. What? 64? 164? Oh no, now it works. What? What is the time now? Now it syncs. But we lose a lot of signal here. We lose a lot of signal. $66. It dropped a little. Oh, you know what? Now the reload doesn't work with the sync signals. Oh no. Oh. The vertical syncs don't work properly now. Shoot. Okay. This is the first problem. Let's check how much RAM do we have left. 8 kilobytes is used. How many lines can we do? 2, 3, 4. Oh wait, flash, RAM. Oh, here we go. Nine of 12. Five. I hope it doesn't optimize it away. No, it optimizes it away. Shoot, we don't have any RAM left. Let me do video line 2. What does it do with that? 11. It's done. We have only 2 lines. Oh wow, this will be hard. Oops. Stuffed. Yeah. Seven. Let me check what is the last line. 281. We need also to set both. Oops, yeah, line. Line. Huh? What? Did I do something wrong? Yeah? Okay. Let me do it then. Are we correct? 287 and minus, yes, 306, that's all right. You're right. Video line. I need to fix that with the sync. Reloading the DMA needs to be done better. Or the sync needs to be done manually. Oh, I'm getting tired. Okay. But we need to let's do an increment for the lines. Yes, that's the CH57 whatever. I don't see a number, it's rubbed off. It could be 70. We're not using the Bluetooth anyway, so and what is the number, line number? Is it a capable? I'm just started using it. That's the first project. It looks alright. The DMA reloads for quite a long time. It's a little bit odd. I need to read the data sheet on that. Yeah, for that price, certainly 100 megahertz. With internal flash, you have to consider that. Some MCUs come without. Doesn't have ADC? Really? Let me check. What does it have? Feature. It has multiplication though. That's even better than the CH03s. 250 kilobytes of memory. SRAM is way more. You are right, I don't see clock real time, Bluetooth security properties. I'm wondering if we can reduce the stack or something, but we would need like to change the configuration. I need to see what it does with a completely empty sketch. Yeah, doesn't see. Oh, we have. Wait. Key detection, analog voltage comparator here. Equivalent to 4-bit ADC. USB 2 controller, that's good. It can be programmed over USB, that's cool. The main frequency timing of 16 megahertz. UART, SPI, I2C. Video. Tuaya radio package. Okay. Bluetooth partner. I tried. I don't know if you can control the Bluetooth or the 2.4 gigahertz thing that precisely that you would be able to send lines. At least you can't use it as a transmitter. I didn't see anything on the oscilloscope. I didn't receive anything. It was really strange. Okay. Start will be and 1. Let's do X. We have only 300 pixels, but we can just overwrite the black level at the end. The blank things doesn't matter. Send images. You'll see. USB can be done. Serial, whatever. Let's not think too much about it right now. We can use the 2.4 gigahertz transceiver if we want to, or USB. Wait, we can do. Wait, line. No, video line X plus, oh, what's that? Sync, pixels, sync and front. Those pixels, sync, front equals X is line number what level white, level black, we just draw a triangle here. It's all not optimized, so please don't judge me that I do like this 2-line buffer that will be just line 2. Okay. While line number equals outline. Let's hope we are faster. Old line number. Okay, here we go. Let's draw a triangle. Okay, peeps. Moment of truth. What? Oh, it didn't compile. What was the issue? Oh, not line mem. What I'm doing. Video line and video line 2. Here we go. Okay, let's go. Ah, it loses sync a little bit. Yeah, it's still off. We have an image. Houston, we have an image. A little bit, yeah, a little success. All right. Yeah, the line is probably. I'm wondering if we are taking too long. Let's try. Maybe we are rewriting. Wait, we need to write to line 2 while it's. Oh, wait a second. Do we write to the right one? Line number. Which one is it that we start with? 6. 6. No, that's correct. Let's try at 100. Maybe we are not fast enough with updating the buffer. Ah, no. It's not that. It's funny how it struggles to refill it. Oh, wait a second. We never return from the interrupt while it's. We need to write the next. Oh, we are behind one line. So this doesn't work. Still. Yeah, it loses sync. Let me check on the scope. What's our time? Yeah, it's 67 microseconds still. That's why it's so off. Damn. It doesn't do anything. It looks like the DMA isn't able to reload any faster than what we do here. Wait, it does reload? No. Hey, Mock TV. Ah, ja. So langsam. It's still too slow. I don't know why the reload value, look at that. If we can't, like, what is this pixel reload that it like ignores? Does it? No. Yeah, it's not the first time I'm doing that. Let me just out of curiosity swap that. If I got it somehow wrong, the counting, because we need to modify the off screen. No. It waits. It waits for the timer interrupt to increment the line number. We could do it always like fills. We have only like 2 lines that are alternating of memory buffer, and then we try like to fill the next one and wait for the one to be shown. But it's like off. I'm wondering, the odd thing is here, pixels reload. It shouldn't even show like this the full screen here. Wait, did I miss something? Oh, we shifted right. Oh, damn it. That's the issue. Okay. Let's try again. And I'm wondering why the timing is off. Yeah, it's trying to optimize stuff and then fail at it. 7. Okay, let's do 40. I was wondering why it shows too much. Let me check if it improved. Okay. Oh, it's too fast now. It jumped. We have only increments of 4. So odd to control. 61.5. What? We had, okay, 36 then. Internal flash is serial. What? Really? I'm wondering if this here is stored in the RAM. Let me do that. Yeah. We lack some memory here. But I have an idea. Let's save some memory. Wait, it didn't compile. Oh, damn it. It looks smooth on autofocus. 360. Wait. Did it compile? No, it didn't. Ah, it's still... Yeah. Soft RAM. Yeah, these things are hard. Okay, now we go. Oh. Did it die? It doesn't have anything for stack left. Oh, yeah, I know what happened. I'm overwriting the memory here. Aye. This is no good. Yeah, this is aligned 36. The last one kills me. This we need to optimize the things at some point. Download some more RAM. We can do some other stuff. Let's do the following. Uh, 400. How many minus reload 36. VRAM will be we have 4 lines. Yeah, we need to rewrite everything, my friends. Thank you for the follow. Rewrite everything. Okay. So also let's remove that. We're not doing video syncs anymore like that. We need Foo! What? Thank you very much! Why didn't the super sticker didn't work? We need audio. What happened? Wait, let me debug that. Yeah, no. That should show anyways. I want that. I want that anyways. Okay. No spoiling here. Ha. Foo. $50. Okay, that's the 71. 90s. Huh? It's filtered. Why is it gone? It didn't show. Objects data. I need to find out why the message isn't shown. Contents live chat renderer. Where is it? Sticker. There is the sticker. Purchase amount text. Wait. Maybe super stickers fall. Actions. Message. Texts. Oh, look at that. That was the issue. Super stickers don't have a message, so I need to add it here. and deploy. No, I never did that like that. Now it should work. Okay, let's continue. Why isn't it? Why is the image go? Oh yeah, Hey Ray, you're a little bit late. I have booster still. I finally fixed the super chats, I hope. Ouch. Okay. We need to find out. Okay. Fail. Wait. Set video line. Set video line. Oh, that will be way better than before. Set video line, not black. No, sync. Video. Set line long. Okay. And then do. Yeah, there is nothing on the screen. That's why I can focus on that. So video. Wait. Where is our here? Long. Okay. Set. Okay. Why? Bolek and Lole. Matt and Pat would be the ones that I would stream. Why line number is not last line is 311. Wait. We could do like in advance, like render in advance, but let's do with that. Video. No, VRAM. And that will be we can do that in a second. Probably need to remove the jitter in some way or form. VRAM 0. Wait, what did we do? Set line. Oh. We don't need to wait for now. We 0. something like that. And then we will do, we don't need that anymore. We have long, short, 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 short. That's 2. Short, short will be 0 again, and then 5 lines. That sucks. You know what? We can start from short, short. Or let's start from 3 here to 3, 0, 1, 2, 3, and then we start the lines with yeah, we can place that in the front. Yeah, vsync. I would do. We don't need to wait. We have like 4 lines of that we can prepare. That will be way better to do probably, but I want to start with that. What do we have? 309, 310. No, wait, 8, 9. That we are waiting for the previous line to be done. Short, short. Oops. I do. Wait, is it 2? No, it's 3. What did I do wrong here? Oh yeah. We start with. That's correct. We will move it to the front because that's actually right. Short, short. Let's move it to the front. Then we have a start of the frame. Oh, field, it's field, huh? Field, fields, and this is the frame. Frame 4. 1. 306, 304. Oh, we can do old now. But this will, we will lose thing here for sure. Y plus, what is it? 3. No, 4. Okay. Set line black. Frame, and then we might want to fill it somehow. Fill frame. The naming is bad. Alright. Sync, okay. VRAM Y and 3. And then 4 in I. X. What is it? 300. Did we do 300 now? Yeah, we don't need that anymore. That crap doesn't need to be there. Line number sufficient. Okay. 300, yeah. XRES. Yeah, I can do XRES here. XRES X++, and then pixels sync plus pixels. I hope the optimizer does the job for me, and we will fill it with level black plus XRES and 8. It's odd that we had like this sync signals only with the white, maybe we get some problems because of the bright signal here. I should have tried to draw a gray signal, a gray. Yeah, that's a gradient. Black level VRAM, but I don't know if I'm fast enough here. 304, 300 plus 4. Wait a second. This one waits for 8 to be done. So let's remove that because this is happening here already. All right. Yeah. This is already done here. Wait a second. We wait before we write the line. So this is wrong. This needs to be here. This needs to be still there. And how we write here, line number is 3. Yeah, that's correct. Okay, now it's right. I do more and more more errors here. VRAM 0. Wait, what? There's no cast? What was that? Oh, this is difficult. Hey, thanks for the follow. Line number. We do -1. Wait, this is 5. This will be, no, wait, 5, 0, 1, 2, 3, 4. And will -1 and yeah, -1 and 3. We have 4 lines that we store. And that. Okay. this doesn't exist anymore. The first one doesn't matter. So now we need to implement our stuff here. Short, short, long, long. Set line short, short, okay. Set line. Oh. We have one long short as well. Long short. Is it there? No, short, 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 short. Wait, that's the long short, yeah. Long short, okay. So we have we might need to extend the sync signal or reduce. We can increase that to 30, reduce that, or even to 32, I don't care, 48, and then reduce that to 30 pixels reload, because in that case we need like the short and whatnot. Let's try to I want the sync signals to be present. Reload. Okay, so we do long. That's basically pixel sync minus pixel reload. Okay, that's, and it will be line. Okay, and int. Now I can try to, I don't know if the optimizer does that, but we will do this. Pixel sync, and then let's hope that the reload. Okay, that's line long. Okay, and then we have short. Yeah, I just remove that. Long. Did I remove the other ones? Okay. Seems I have short. Okay. So the other one will be short. That's basically minus. Wait, that's. Oh yeah, pixel sync. I need to swap these lines. What am I doing? Editing the wrong one. Okay, let's keep, this is still the long. Okay, long short. In that case, another follow, thank you. We doing that. Then we need to do that. Short, and here is pixel sync. Okay, this is the short. Long short, and this will be short. Short. And that's basically that, but without the reload here. Okay, if short, then set line sync. As basically pixel sync, pixels front, then I plus equal xres, and then we have, that's the black. That was the filler. Pixel reload. Okay. Pixels back minus reload. Reload pixels back. We might want, no, we need to keep it shorter than that. I have no clue if that will work. I think we are done. Are we? Is there something on my stack? 3 errors. Syncs. Video. Set line sync. The first line will be random. Oh. Uh-oh. Odd state, huh? Oh, wait. Okay. We might have an image. It loses things. But I don't see. Okay, let me stop it and see. You want to see something? Ah. 61 microseconds. Oh, the reload, Christian. you might have been really helpful, because it seems that not using the flash here might have helped. 61. Let's do reload. Oh, but we will... No, we have enough RAM. We only using 62%. Oh, there was something odd. What is this? What kind of oddity is going on here? Oh, weird. Okay, let's do 0 then. And run with it. We have only minor... Oh, we have hiccups here. We have hiccups, but what? Why? Why do we have hiccups? That's a weird thing here to see. Are we filling that buffer with something weird? That looks like a bug to me. Okay, level black. I will just do level black then. Yeah, that's all right. I think that happens if you have a bad sync. Huh? What? What is this? It's weird. Sonic, you're here. Oh, I know what the issue is. I have a fixed offset here. Just using some RAM. Oh. Nothing. Uh-oh. Why is it? Hmm. Hmm. Now it doesn't work at all. Why? Oh, wait a second. Does it maybe never trigger here? Yeah, it should. It's restarted. Huh? I don't know why it would not work like with... Huh? That's weird. Okay. Let's do 20. Oh, you didn't see that? Yeah, we had already a strange... Why? It stopped now. We even showed... Oh. We even showed a triangle. Scope... Oh, yeah, no. Now nothing works and I don't know why. Huh? I'm really clueless now. What happened? I hope I didn't kill it. I just recompiled VRAM. What was the last state? 40? Hocus focus. Oh, let's do 0. %66%. I know what's happened here. All of the sudden... Okay, let me try to loop. It looks odd to me that it wouldn't work. Reload. What is... Oh. Mixed cases. Nope. Huh? That's really odd. Okay, let's give it a rest for a second. I have no clue what happened right now. Maybe I will rewrite the flash or something, erase the flash if it's in an odd state. Did I break it? Oh, it's 2 o'clock. Let me fill that for oops. Now what? Okay. Why is the center overwritten? It's 10 a.m. somewhere. I think level sync. Express. Pixel reload. Pixel sync. Pixel sync. Line long short. Long long. Oh wait. Did I? Yeah, I am in loop mode now. Let's fix that again. Oha! There are lines visible, but there is still this odd sync in the center. Let me try white here. So I know what I'm talking about. Hello? It's always this signal. Like it's sending short, short. What if three oh seven? Let's do that. Let's start with that. Yeah, no. So we start fade, yeah. 307. It increments. You know what? Oh, yeah, it failed. Okay. I do the following. I will increment. I will do all of those like that. Yup. This one died. Okay, let's try again. Here we go. There is something. Is this short signal? Okay. Short, short, level wide. Let me just test if it's all the same buffer. Yep. It's always only the short one. It never continues here. It's volatile. Volatile. I hope it isn't optimized. And now doesn't fit anymore. Oh. Hä? Am I blind? Volatile. Uh, yeah. Yeah, that's the shit. Again. Yeah. No, 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 no. I will continue until we are done with that. Okay. Something's off here. For me it's perfect. I love this. Yeah. I'm wondering if we should write 4 lines at a time. We can't do line doubling though if we do that. So mode single. Why not line number? $300. Yeah, but then we have like the reload time will be taken off the last line only. Let's see. Do I see a problem here maybe somewhere? I'm wondering if it reloads the address somehow before we can modify it. So strange. Short. Okay, let me check first. Level sync if we are right here. Let's just do one line, or let's not modify that at all. I just want this to be here, pixel sync, and then pixels per line minus pixel sync. Okay, so I expect wait, yeah. This. There are issues. I see issues here. It has a hiccup. Let's fix the hiccup first. So I'm wondering if it's that here. The order. Oh, interesting. Now it works or what? Huh? But it loses sync sometimes. It's so strange. Okay, let me check what the timings are. Oh, we are way too short. Why are we short? No, wait, we are not. I need to change the cursor. Here. Okay, we are too long. Now we need to add that again. Let's do 20, reload of 20. We have that here. Let me check if that helped. Oh, that's too short. That's too short now. We lose sync here. Okay, 20 is too short. 16. We have only like I think it looks better. Oh wait, wrong. 64. Now, yeah, it is 64 microseconds, except for sometimes where it loses sync. Had some hiccups here and there. Should I test if we have decode? Maybe we can let's test it if the vertical sync is working. As sometimes we lose something. Okay, let's do. Might have to do that we are too slow. Need to prepare all. Wait. I don't see anything. Oh wait, level white. Nah, level black plus. Okay, here we go. No gradient. The hiccups are not in the same line. Maybe with the vertical sync we can see. I could try video decode, maybe analyze. I don't know where it is though. Features. Video. Okay. I can try video. Standard PAL. Okay. Yeah, I don't see. Analyze menu, auto setup. Okay, that's the auto setup. Okay. That's my video. Okay. Yeah, that doesn't help. I don't know what it. Does it show anything? What's the analysis? Lines. Vid auto. Yeah, it doesn't. I don't know. Generic. Oh, you're right. I'm wondering if it if is debugging or whatever. Looks odd. This is when it's always happening when at the same time when we lose the frame. Might be interfering with our read and write stuff here. We can do the following. We can do line number -1. What if we do 0? Same. +1. +1 should be basically 3 lines behind. Nope. And this is odd. It has to be like something with the timings here, what to do or not to do. But I'm wondering why I don't see anything here. Okay, X. Y. Level gray. Okay. Let me try to draw a triangle. Oh, it's doing only one frame. Wait. We are too slow here. We are losing. Yeah, we are losing a frame. We are losing a complete frame because we write too slow. Oh wow, okay. Let me shift it by 1. But yeah, there is no way we can do that. +3. We are too slow with the branch prediction or whatever it is here. We are waiting for a complete frame. Oh, every time we're done, that's where we lose sync. So basically trying to write Oh no. We might be just too slow. If the RAM bus, because of the DMA, the RAM bus, the bus might be completely stuffed and we can write in time. Ay, 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 ay. What do we do here? That's why all these things don't work. Okay, let me try something else. Yeah, mostly. Some tweaking required. Okay. I need to change something that will be not great, but not that bad. Let's try to run pwm config at 8. Times 1. So the timing is still there. Level black will be 2. This will be 5. Gray 8 will, yeah. Where's white? Oh, white is 8. What is this? Ah! Can I close that here? How do I close that? I don't want this anymore. Ay, auto scale. Ooh. Yeah, it's still. Now it's even off. Oh wait, I'm repeating everything twice. Oh no. That's not what I wanted. Yeah, pwm config. Wait, no, it should be like that. Wait, let me check that. I really just want to. Yeah. Come on. Let me move the cursor. Oh. Yeah, this is not. This is this is not what I want. Wait. Times 1. Oh. There is only. This is times 4. Huh? 4, 8. Even with 4, why? Huh? Yeah, the datasheet is really bad. 0. PWM config. Clock source. Okay. Lines, okay. This is still let's do short. 4, 5, 6, 7. I need to try different things. I have no clue why. Okay, I halved the resolution just to test it. If it's me you're looking for. Okay, and then we do, what is the total? 12, 3, 4, yeah, whatever. Let's do just line number. Yeah, it's not the last 5%. There is a lot more. Why is this marked? Oh yeah, volatile. Wait, why line number is 312 is total. And this will be wait. Why line number is wait smaller than 12. Oh, my brain is already frozen. 3. No. We have 12. That's 12 minus 8 is 204. 2. Five, 6, yeah, I had no no cheese today. It's already stuffed from the bolognese that I got. Okay, 9, 10, 11. Okay. And now the frame starts. but this is okay. This needs to be is greater than 0. No. Smaller than 311. Then it fills the last line of the sink. Number is equal to y wait here. Okay. We are ahead, 8 lines ahead. VRAM does that and 7. Okay. This is quite complicated, but okay. Let's see what happens. We have some half frames here. Ay. What is this chopped up signal? Oh, yeah. What is this? At least it doesn't have any hiccups. I have no clue what that signal means. Let me do level gray here. We have the issues again. The issues are back. No, this something is off here. Did we change to 32? Cycles configuration. Yes, we did. Wait, did we change it here? Yes. Oh. My battery died. I need to get a leak. Take a leak, sorry. Not get a leak. You watch that while I am gone and I'll be back in a minute. Oh, thank you for the follow. Back. All right. Second ear. Okay. Let's take a look what I did here. Yeah. DFGA, yeah. For sure. What is happening here? We have wrong timings here. Line, full color image, yeah. Okay, there's one error. Didn't update that part. Ooh, doesn't look that bad. If you it's scrolling up. It's a scroller. Pew 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 pew. Okay, it's really odd. Let me get my test image again, my test scan here. Why is it full? I missed something because it's always let me check the duty cycle here. Okay. All test level black. Okay, didn't change anything. So let me do that so I can see the actual. Okay, so we see this is the. Oh, that's cool. This is now really synced up. I can see the actual line length. But unfortunately, peeps, I can see the same issue as before. And this is, what is it standing on? Oh, it's on the cable here. That's why it's tipping all the time. Okay, cursors. Where are the cursors? Let me do measure. Trigger. What? Measurement is period. Okay, it works now. 61 microseconds. Okay, that's too short. Level reload. Let's do 0 again. Now it works or what? Strange. Um, 63.5. No, this is wrong. Measurement is wrong. I need to do it manually or it doesn't happen. Okay. 63.5 and there is some odd behavior. That's something. Okay, this is long, short. But why is it? I see long, short, and then it stops working. Oh yeah, short. That's what we got here. My debug stuff. Okay, let's remove the debug stuff. It is strange that the behavior is really random. Okay, still. Wait. Long, short. Huh? Oh, level black. I used white here. That's a change that I did long time ago. And I was wondering why it does this strange stuff. Okay, now we have the sync signals. So we have, oh, this is long, short. There's a little bit, this is like we have some issues here with the restart. It seems like sometimes it skips a few, or wait, no it doesn't. We clip it somehow by resetting the DMA or something too early or too late. Yeah. Okay. Need to figure that out. Let me check. Okay, short. Yeah. The reload needs to be 4 or something. Reload needs to be 4. Let me try that. No, still. The frame looks odd. Let me try 8. Nope. 12. Nope. It shifts each line a little bit. And I don't know why. It's so strange. Let me move that back to where it was. I can put it here. Yeah, that doesn't reload. That doesn't do it correctly. If I don't do it this way, it doesn't work. Okay. Okay, the next issue, I'll just skip it for now. The next issue is that it does a few shorts, like short, that's that, short, then it does immediately the other shorts. It completely skips the loop here. So this never triggers. It starts over again. I maybe should do a queue or something. Just filling the one the next one as fast as possible. This one here, line number, okay. In it, yes, no, it isn't. Yes, it is here. That without that it didn't work, and that's odd now that it doesn't work properly if I init it. I would probably need to TMR disable before I reset this, because it starts over again and then it never changes the DMA address. It reloads the old one somehow. Okay, I need to grind the data sheets to figure that out properly. But what I will do next is do volatile and draw line and okay, line shown, line drawn is basically also Okay, in that case, I do 7, and then draw next line. And then we do the following: while line show is makes much more sense. Line drawn, wait, and shown, and then fill the line. Line drawn, switch, line drawn, case, let's do 0. That's 1, 2, 3, 4, 5, 6, 7. Short. DRAM line drawn. Easy, huh? Sometimes I need a little bit of patience. 3 and 4. Paired break. Oops. Set line long. Line drawn. Break. 4, 5, and default. I make it look easy. Doubt. Sometimes. I don't know if that translates easily, but we need to do it like that. Okay, so set line, and now we do the following. This is we can render line. No, set line. We need to do this. VRAM. So overcomplicating things here. And then we need also to do this here. Oops. Yeah. Bloop. Oh, wait. We just do, yeah, we can do 4 or something. Or, wait. We can't draw the last one. No, we can't. Oh, that's that's interesting. Because this while, draw next line. Okay. Draw next line. Oh wait. Let's start at -1. It's always, yeah, perfect. Okay, so we can do draw next line. Will be it. Draw next line and then VRAM single. Yeah, we don't need that. Draw next line. Easy. Yeah. Okay. Failed, okay. What are the problems? Oh yeah, line number. It's not line number anymore, line shown. And we need to add here line drawn plus plus okay, and same line shown wait a second. Index and here. Oh, this is also a thing that we can improve. Because line shown line shown can be just line shown equals line shown plus 1 and 7. So we don't have an if anymore. And that might have been also an issue here, because we tested it later. It was a bug. What's the matter? Hey Terran! What's going on? And now let's download it. Ooh, it loses sync for some reason. So, some unrelated reason. Ay, 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 ay. Why is it odd? No. It's all perfect. The only thing that now is odd, that it doesn't work anymore. No, it's not 0. No, you're wrong. Yeah, scope doesn't like it, what I do here. Okay, let me line drawn. Oh yeah. I need the index here. And what's this here? I'm writing somewhere in the RAM. Yeah, it is, but it's not really. It's all analog, so don't worry too much about the level. Oh, it's all over the place. What did I... This period measurement doesn't work properly. Manual, okay. Where's X2? No. What is this? 95 microseconds? This is a reload issue again. Okay, let's move it back again. Also, line shown needs to be set to 0 here. That's that. Okay, at least we got our video back. Yeah, it's 64 more or less. Oh, it's a little bit longer. Uh, 65.6. Okay, it's off. But why is the sync so odd here? I don't think I have purpose sync here. Imagine I hear things. Maybe it's raccoons outside. I think this is the start of the frame. Let me zoom in here. We have short, long, long, but then, okay, video signal, and this would be short, long, short, 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 but there is no sync whatsoever here. Huh? Something, why is this? It's like there is twice the sync here. 3 times, 4 times. The sync gets overwritten. Okay. Look at this. We are in trouble, peeps. So we have a short, long thing, and this is how it manages in 8 lines. It only manages to fill the short sync by, what is it, half a line. We can probably see that doing this here. We just increment that's pixels per line. X equals, and then we do level sync. No, not level sync, level wide. A level wide is distinct for that one. Okay, so here we go. And this is what I expected. Let me try to capture that. Here. I think no, this is where it refills. Can't catch it. But maybe I need now. This is already. Let me read it here. Okay, so let me show that in full screen. You can see how this buffer, these seven lines that we got get slowly filled with the high value until it's at some point it should go. Yeah, that might be the glitch at the end, but why is it though? 0. Okay, this is probably where it turns off. But here we go. This is like 7 frames, and then we see like 3 speckles or 4 speckles. Do we? No. Yeah. I believe it's just too slow. Let me try something else. Oh, let's read the datasheet. I mean, I'm here anyways. But DMA should do it offline. Let me see. Architecture memory. Okay, timer. Address, data bus, interrupt, DMA, arbiter. Here. it shouldn't be that busy. What are we doing right now? The frequency is 160. Yeah, no. Or is it like reading whole blocks? I mean, if it's if the flash is serial, it might code area of data area as from peripherals. Christian, where did you see that with the RAM and with the flash that it's serial internally? Memory mapping. Let's see if it says anything about let me get that on camera. If it's a fail with the PWM DMA. I'm not sure. Okay, interrupt system control. Reset. Hmm. DMA count buffer address. Begin and end. This is interesting. We could use the address and not the interrupt controller to refill it. Timer control. That would be interesting. Not using using the loop mode. I'm going to see the sun again. Maybe. Tony's getting up 5:30, so I'll probably breakfast with her. Or make a coffee. Yeah, I will probably try to do some oddities with the address. If we can run it in loop mode, we save a lot of time on the interrupt controller. But I'm not sure if we can, how fast it can go. Keyword SPI characteristics 8-bit data transmission. No, wait, no. High bits in the front check. The 8-byte V454 SPI. If SPI would be to my wire, there is no SPI with 3-wire selection. PWM. What is this? Synchronization. Sync enable, sync start. Probably PWM channels that are synchronized, huh? DMA address. Interrupt, okay. PWM is a lot of stuff. DMA function. A read and assign DMA and to any value that is not equal, for example, oh, okay. So this is how you enable the interrupt. Not equal, for example, value now plus 100 clear. Okay, that's the DMA function. Okay, key scan USB reserved, yeah. Wireless communication parameters package. Is there a DMA for general purpose? Yeah, it doesn't look like. No. Okay, the design is quite odd. The CH32V03 was easier in that matter. You could just write to any address, I believe. Let me search for DMA. Timer. Yeah, timer. Here, timer again. Timer. Timer. Bare metal stuff, yeah. Timer, DMA. Okay. No, they're just hardwired. The DMA is not. DMA buffer current address. Yeah, now, yeah. Starts. I get an impression how this MCU is designed, and it looks like if we can't make it work with the PWM DMA or SPI, maybe. What's the maximum timing? In, out. Yeah, but why would it be different to PWM? Yeah, DMA. The only thing that I can imagine that might work USB. Nah. How big is the FIFO? But USB, the encoding is, there is no like long ones or whatever. It's always switching after 11 bits or something. The polarity, that would be awful. Receiver FIFO. That's the USB peripheral. Wait. Oh, the buffer is only 4 bytes. Start address. No, that's the start address. Okay. endpoint buffers. Yeah. Okay. Wireless communication. There is no description whatsoever. Oh, I can't hear you. Why? Did it stop working? Ooh. Let me check if this server's still running. Can we see? Where is the chat here? Oh no. Yeah, still running. But this one isn't. Huh. Sir? Aha! Connection reset. What? Aha! Okay. Oh. How do I kill a task? It's still running in the background, but somehow died. Is it Node that's dying like that? Okay, I can maybe check here, file manager, system, running processes. Okay, here we go. Apache. Huh? Hmm. What's the net stat? Net stat. Huh? I don't see it in use. Oh yeah, here it is. Ah. Can I see the PID? Okay, let's do this. Eight, 444. Wait, what? Doesn't work. I have plenty of. And what is the? Ay 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 ay. Huh? I really don't want to restart it. Damn it. Let's continue. I really want to hear it if someone says something, especially if it's only few users left here. Oh. cd repass now. Okay, you're right. I probably have to restart. But I want to wait. What did I do? Net start. How do I get? P. Okay, let's do. All right, here we go. I just need to show P but what? TCP, but it doesn't show. Oh wait, PID name here. 8444 here 79779 system. There it is. Terminates. All right. I like visual tools. Ta-da! Okay, now I need to find my node red. There, and poke it. Here we go. Okay, authenticated. Now, where's my chat window again? Here. Okay. Works. All right, let's continue. Just timed out the session, but how do I reconnect to a session? I started the process and then that's the okay. Let's get the back. Frame interval. How big is a frame? Maybe it's possible, I'm not sure. Currently it looks like the bus is blocked. It draws too slowly. Oh yeah, I wanted to test something. Let's do that to confirm my suspicion. So what we can do is attribute align VRAM buffer. We don't need to align that, and VRAM will be like that. Let's do 9. Okay, let's revert that frame lines 312 and VRAM let's do more. No, let's keep it with 8, and let's do this again. What we did before. So unfortunately we need to skip draw next line and initialize it like this, or let's do it like this. And we will just prepare one frame that shows whatever fits. Hope we have enough. Yeah, we should be frame lines. Frame lines 0. We need these 3. We could maybe optimize stuff there, but not that much, I believe. And it takes so long to fill one line. I don't know if it's because of the interrupts, but it doesn't take so long. Short, okay, that will be basically 32T and then VRAM 0. Okay, so we have 1, 2, 3. Four, 5, 6, 7, and then we have long, 2, and then short. Okay, and then we prepare like one frame. Yeah, for 12, that will be 8 to 312 plus, and that will be frames I is 3. Let's reintroduce it's too bad that we don't have DMA descriptors, otherwise we could build a nice nice frame, and that will be basically frame line 0. Okay. I change that to the new, and also that. Oh, I can do the following. Do that address cleaning here already. Yeah. And I need to refill that last one. Okay. So no need for that. Current line. Okay, and that's not the VRAM current line, it's frame lines, current line. Okay, and that's all right. Okay, let's fill the last one here. That was what is level black? Level black is 8. Yeah, let's do 16 plus x and 15. Just some gray stuff here. VRAM 3. Okay, it's prepared. I hope this is all right. Yeah, that's what I thought. We get nice gray values. Our sync is a little bit off. Why is the sync moved to the right? Okay, we can try to get more lines here, like frame it a little bit, or how many buffers do we have? Can do 4 buffers, so 3 plus, we have 8 plus a J. It's shorter than, oh wait, what do I do? Here is where I want to be. Okay, so 4 J plus plus, and what I want to do is X plus J times 2, 3 plus J and this also. And frame lines plus, wait, no, VRAM plus I and 3. Okay, now we have, let me see how many RAM, we have still, I don't know if we can fit another few lines or whatever, but here we go. Yeah. Now they are shifted, but it looks awful. They shift too much. Okay, let's do not times 2, just plus j. You can't even see, huh? Okay. Times 16, no, times 8. So it will shift by a lot. Oh, no, it interleaves. And we don't see anything. That's strange. Okay, how do we do checker? I want to try to allocate more RAM here. 8. Can we do 11? Please fit. Oh yes, we can fit 11. Hey, Spaceballs! Yeah, we're trying to use 10 cent risk to make a video signal, but the DMA is basically occupying our bus, and I don't know if it's fetching code or whatever from Flash all the time. Maybe the only way around would be to put the code in RAM and run it from there, but I don't know how to do that. I would need to figure that out. But I don't know if it's the Flash or what the issue is. Yeah, it could be code from Flash. I don't get lots of information about the design or internal design. If it's like caching, Flash or whatever. Okay, we can do 8 rows J. We can do 8 rows. Plus J. Okay. 8 rows. And 7. So we could actually draw text now. Let me show you in full size. We could draw text. Let me shift the frame. Aha! Okay. Maybe 10 and 24. So we recenter it. Now that looks promising. Not sure if we are too far. But that looks way better than you would think. Let me get you closer. Okay. Do we need some character ROM? Hey, thank you for the follow. Eight by 8 pixels. Okay, I let ChatGPT generate a character ROM. Oh no. Okay, C array. Oh no. Okay. It's generating the characters. Okay, maybe we need to add source, new file, charset h. Here we go. Is it done? Okay. Pragma once, and then we do we don't need that. Font 8 by 8 and then hide. I don't need that. I don't need that. I don't need that. That's all good. Font 8 by 8. Include font charset. I should rename it. Not charset. Rename font. Okay. Now let's render. Render it. Wait, where am I? Here. Let's do Y here. Okay, and then let's do we have no aliasing or whatever. Level equals basically what we do is x divided by 8 that's and yeah, that's that. Bit is x and 3. I am level is basically, it's not, wait, didn't I rename it? Add existing file. Okay, here we go. Level font 8 by 8. Yeah. CH, and that will be Y. Shift right bit. And 1, and then if it's 1, then level gray, otherwise level black. Oh wait, no, let's keep the grayscale and then let's just do white. So if and 1, then do level white, and we don't add the shift here, we have just that. Okay, is that all? Yes, I think so. I hope it doesn't. Oh. Problems. Oh, plus Y. What else? What? ChatGPT, what did you do? Here. Several times. Okay, I hope this font is any good. Here we go. Okay. I don't know if you can see that. There are characters. Okay. That is getting more interesting by the minute. Can we do 25 right now? Okay. If you squint and go sideways, no, it's really there. You want, okay, let me do the background a little bit lighter, I mean darker. Here we go. Background will be okay, let me do the background black. No, it's not. Here we go. Oh, is it? No. Can't tell. We need to write something like bitluni. Okay, let's try. Text. Yeah, we will never be there. But character is X, and that will be text. Oops. Okay. Or Yehud works and never fits. Okay, let's see. Oh, we need to minus 32. Now I will not, I don't know. Oh, it might be rotated. No. Huh? Hey, Dutch maker. X-res is 150. Yeah. 17 carat. Yeah, let me. But I can't read that. That's like. Okay. Hey Fu, you're still there. Yeah, but it's not, we can't write into the RAM at the same time. We can double the lines so it will be more readable. Okay. What is that? I think ChatGPT screwed me over. What kind of characters are those? Okay, I need to yeah. Eight by 8 font. It's not Chinese. Monochrome bit. Oh, here we go. Machine readable. Control X Greek. SGA block box basic. Okay. Public domain. Yeah, I take that. Static font 828. Okay, so we won't do anything there, like minus whatever. Okay, so ChatGPT font didn't work well. Let's see if this one will work. Yeah! It works! Okay. That's what I'm talking about. Yeah. Okay, yeah, we have some line doubling here, so we can let's put something in the background. Now it should be, yeah, you can't read this if we do it like that. All level black, let's do black. It's so funny that we can do PWM. Okay, yeah. Bitluni was here. It can't read it well. 7. That we can get this grayscale even with PWM. That's cool. Nice. I don't know what ChatGPT did. It was strange. The characters were off. I'm not sure it was rotated. Oh, so tired. So our stream is running already for 9 hours. Yeah, what a long day. The only issue is I can't refill the buffer while it's running because it's too slow. The bus is blocked by the DMA. At least it appears like that. I will try to tinker around to find a solution for that. maybe we will need to do everything manually, but then yeah, during the sync phases might be some time. So we have per resolution. I have 8 buffers. It didn't matter. It's just like the either one thing that we could try is to put the code into SRAM. It might be that basically the code is too slow, but I have no details whatsoever how this processor works internally. So I could test that, but it's a lot of work. So the only thing that we could figure out is that it's really slow when I try to do it like that. The only thing that I can imagine we can do from here is try to somehow utilize the sync signals to fill the buffers, but then it's basically completely over. How much time do we have? Like few microseconds in total, and then we would need to switch as well. All right. Oh. I lost my connection somehow. Strange. Where did it connect? Oh. Bluetooth, okay. Okay, let's take a look. Let's switch to this while I'm looking for the timings. Okay, here we go. Interesting would be if we can manage to transmit data packet using the radio. I have, I think, 2 of those devices, and you can connect it basically to USB, or we can do like a USB serial with that, but I'm not sure how that works. Especially, okay, USB has some buffer, but yeah, that won't work. And this will break apart. UART has only 1 byte probably. Let me check. Byte FIFO support trigger stages. Okay, we can send 8 bytes at a time. What does the SPI support? It says 8 byte. The wireless, it doesn't say anything, I believe. Yeah, USB. Richard, you can try now. It's a simple setup. We had it's only like 2 resistors. This is, I think, this is 200. What did I use? 220, and this is 100. So, and there is like a small, what is it? That's 1 nanofarad capacitor, but it will probably work without the capacitor. The TV is able to do that as well. I didn't upload the code yet, but yeah. Oh, I'm really tired already. Okay, 20 more minutes. All right. What did I want to do? We can zoom out. bitluni was here. You can display something. I mean, we can do make alien Earth computer shows on screen. Crew is expendable or something. Lorem ipsum. Nah, crew is expendable. Maybe we can even generate the sound. Could work. Movies always do. It looks better in real life. There is no like this flicker. It's only, I think, shutter or something that causes that. It's not perfect 50 Hz. Oh yeah, it's not, because we are using strange ray tracing. Yeah. No. How do I run risk code? Okay, maybe ChatGPT can help me. How do I run risk code from RAM? Okay, let's see. How big is our code now? I mean, I can't copy the character ROM. That's too much. Maybe I can. Let's see. Text 4 kilobytes. data 12. What? What is deck? Constants or that is probably our we use 2 kilobytes stack, and this is probably then our buffers. Let me calculate that. What do? We have 400. No, that's 800. That times 11. Now, and we need frame lines plus 12 times 4. That's oh, huh? No. Okay, wait. $800 times 11 plus 312 times 4. Yeah, 48, and then we have the volatile line drawn, line shown are not used, current line. Okay, yeah, that's the data segment. There's stack reserved for stack. Where's the configuration, by the way? Binary startup. Subtier make. Oh, foo. Good night then. I'll be leaving in 15 minutes as well. Main D. Subtier make. Where is core risk V? Memory mapped structure for, okay, that's only a structure. That's just, oh yeah, that's just basic structures. What do we have here? Memory 12K, okay, origin, sections, here we go. Init, align, keep sort, okay. High code, init, flash, high code text, glue, add flash, s data 2, okay, initialized pre-init array, init array, constructors, destructors, data. Okay, provide stack. Length RAM. That's the stack, but how is it defined? Hey Myland! Hours? Yeah, 9-hour stream. Yeah, it is. I mean, we have something to show for. Look at this. But unfortunately, it's not dynamic, it's only static and it's only one line. Yeah. Oh, okay. My girlfriend will wake up in 15 minutes, so I will stay awake until then. I won't wake her up by going into bed right now. And I wanted to have that finished, and we just finished like half an hour ago. Now I'm checking. Oh, yeah. Now I'm checking how to git stack. It will complain. Let me check something. If I do one more line, it will complain. Okay, if I do that, it will complain. Yeah. Region size 12 kilobytes. Where do I set the stack size? I don't think it will help. Properties. Let's see. You can't read this, probably too small. C++ builds. Build steps. Tool chain editor. Okay, general path symbols. Optimization. Build steps. Nope. location. Yeah, that's the map file. Oh, that's also interesting. Data text, debug init, line drawn. Wait, is this? It's all 0 because it's not used. Yeah, that's all not used. What is this? Debug info. Mutex. Here we go. Interrupt handlers, vector, high code, flash ROM, field text, handle reset. Vector handler. Okay, I missed the main. Nope. Then the map file. Okay, what else can we try here? I don't think I can change stuff. I mean, if I will change stuff, we can see how slow it is, okay? So let's try to update stuff. Oh, actually, we can do the following. We can try to scroll it, maybe. So I will just put the whole thing and you will see how slow it updates. We don't need to do the line sync anymore. We will do the updates here. Actually, that's not bad. Draw next line is not used. Let's do, what is it? Scroll basically and static S++. We can do that. That will probably work, or it will break everything. Yeah, plus S and 15, that will be all right. It will clip it, but that's all right. Wait a second. Does it actually scroll? Huh? It looks like it's scrolling fast. Okay, let's do something else. Let's do pixel-wise scrolling. Plus S. Plus S. So we know what's happening here. Uh-oh. One here. All right. Okay, we get issues here. But it's scrolling. What? We can update in real time. No, wait a second. We update only 8 lines per frame or something. We would need to write it on the fly. So this is the only thing that we can do here. Like scroll, and even that is not great. Huh. Yeah, wouldn't be able to update it in real time. Huh. Why is it so jittery? Probably because I access the same address while it's writing. So maybe I can force it to stop while we can wait here while frames current line here. Y frames current line equals, what is it, VRAM plus Y. Do nothing. Okay, let's try that. Wibbly wobbly. It doesn't manage to do one row at a time. Maybe we need to split it in 8. Ooh. That's really terrible. It was at least a little bit better. But still wibbly wobbly. Alright peeps, I say goodbye for today. It's 5:30 in the morning and I see you the next week the latest. Bye bye everyone. Hey Scott, I missed that you joined. Here we go. A nice view. Scrolling. Don't need that. Oh, thank you for the bits, Spaceballs. Oh, that's you, Scotch. Is it? Yeah, I think it's you. Yeah, here we go. bitluni was here. That's my message for today. Bye bye everyone. Good night everyone. Bye bye. Thanks for watching.